Why bodies float. Learning about why bodies float. Buoyant force. Activity. Take a bucket full of water. Try to push an inverted glass bottle into the bucket. What do you experience? When we try to push an inverted glass bottle into a bucket full of water, we experience an upward force on the bottle due to the water in the bucket opposing the downward motion of the bottle. Take an empty plastic bottle closed with an airtight stopper. Put it into the bucket full of water. What happens? Now try to push the bottle into the water. Is it possible to push it easily to bottom of the bucket? Why? Now release the bottle. What happens to it? When an empty plastic bottle closed with an airtight stopper is put in the bucket full of water, the bottle floats in water. It is not possible to push the bottle easily to the bottom of the bucket. This is because an upward force exerted by the water on the bottle opposes on the downward motion of the bottle. If the bottle is now released, it rises to the surface of water and floats on it. The upward force exerted by water on the bottle is known as upthrust or buoyant force. When a body is partially or fully dipped into a liquid, the liquid exerts force on the body. The force exerted by the liquid is perpendicular to the surface of the body and is equal to product of pressure and area at that point. The result of all these contact force is called buoyant force. Have you ever drawn water from a well? You must have noticed that the bucket of water appears lighter under the water but heavier as it comes out of water. The submerged object appears to lose weight in liquid due to upthrust or buoyant force. The property of liquid to exert an upward force on an object immersed in it is called buoyancy. The buoyant force acting on an object depends on volume of object. The buoyant force is greater if volume of object submerged in liquid is larger. Density of liquid. The buoyant force is greater if density of liquid is greater. Activity. Take an iron nail and a plastic cap of a bottle having nearly equal masses. Put them in water. What do you observe? What makes one of the object to sink in a liquid and the another object to float in the same liquid? When an iron nail and a plastic cap of a bottle having nearly equal masses are put in water, the nail sinks in the water while the cap floats in water. There are two forces acting on a body immersed in a liquid: the upthrust or the buoyant force with magnitude B and the weight of the body with the magnitude W. These forces have opposite directions. The body sinks if W is greater than B and body floats if B is greater than W. You may have observed a case in which an object floats inside the liquid. Under what conditions does this happen? The buoyant force determines whether an object will float or sink in a liquid. A. If buoyant force exceeds the weight of the object floats. B. If the buoyant force is less than the weight of the object sinks. C. If the buoyant force is equal to the weight of the object, then the object floats inside the liquid. Archimedes' principle. Activity. Take a piece of stone and tie it to the one end of a rubber string. Measure the length of rubber string. Now suspend the stone by holding the string as shown in the figure A. And again, measure the length of a rubber string during suspension. Note the elongation of the rubber string due to weight of stone. Now slowly dip the stone in water in the container as shown in figure B. Observe what happens to the elongation of string. The elongation of a rubber string decreases continuously as the stone is gradually dipped in water. Once the stone gets fully immersed in water, there is no further change in the elongation of the string. The elongation is produced in a string due to a weight of stone. The extension decreases when stone is lowered in water. It means that some force acts on the stone in upward direction. As a result, the buoyant force on the string decreases and hence the elongation also decreases. The magnitude of buoyant force and its nature is different fluids for a given body can be determined by Archimedes' principle, which is stand as: when a body is immersed completely or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Applications of Archimedes' principle. It is used in designing ships and submarines. S is a ship which can float on the surface of sea or can sink when necessary and reappear again on the surface. It is provided with large tanks both at the front and at the back. These tanks can be filled with seawater or air from compressed air reservoirs. If the tanks are filled with water, the weight of ship increases and hence it sinks according to the requirement. If water from tank is pumped out by forcing compressed air in them, the ship becomes lighter and rises to the surface. Thus, by filling or emptying the tanks, the ship is made to sink or rise as desired. Various instruments like lactometer, hydrometer are based on these principles. Till a few years ago, lactometer were used to determine the purity of a sample of a milk, while hydrometer is used to determine the density of a liquid. Relative density. Activity. Take a piece of aluminium foil and put it gently and horizontally in the bucket full of water. What do you observe? Now crush the foil into a ball and put it in the same bucket. What is your observation? What will happen if the ball of crushed foil is put into a ball of mercury? The aluminium foil floats on water, but when crushed into a ball, it sinks into water, while it floats in mercury. This is due to change in its density. The volume of aluminium foil is more than the volume of ball formed by crushing it. So density of ball is more than the density of foil. Hence, foil floats on the water, but ball sinks in it. While density of mercury is much greater than water, upthrust is also greater and the ball floats. Density is equal to mass upon volume. If density of an object is greater than density of liquid, it sinks into the liquid, while if density of object is less than density of liquid, it floats. Density of a substance is conveniently expressed in compression with that of density of water. The relative density of a substance is the ratio of its density to that of water. Therefore, the formula for relative density is equal to density of substance upon density of water. As it is the ratio of two similar quantities, it has no unit. Let us have a close look on the solved example given below. Please click on the examples to see them. Summary. The buoyant force determines whether an object will float or sink in a liquid. The buoyant force exceeds the weight of an object, the object floats. If the buoyant force is less than the weight of the object sinks. If the buoyant force is equal to the weight of the object Then the object floats inside liquid. That is all in this topic. Till then, keep learning.